Hey everybody. Today here in Ferreria Math Class we're going to be taking a look once again at some distributions. These are discrete probability distributions, and we're going to be doing the wage data. Oh, we haven't done it yet, so we're going to be looking at wages and data. Of course, as we move to our worksheet here, this is suppose you get a new job and your boss, Mr. Ferreria, that's me, draws a slip of paper from a bag to determine your wage from the day. Let X be the random variable, the daily wage in dollars per hour. So what is your wage for the day? Add the data to the table on the board and complete the table below. So this is another one of those experiments that we would have done in class, but if you're watching this now, then I suppose you're either redoing it from class or you were absent or something like that. But let's just say that you take the wage out of the paper bag and it says $7. Okay, well, you write down the $7 there in the blank, and then you compare with the rest of the class. Well, we don't have a rest of the class here. So what I'll do is I'll construct what happened in class the other day. Well, in class the other day, about 5 out of the 22 kids got a wage of $1. Sorry, $1 an hour is not that great. 2 out of 22, got a wage of $5 an hour. Still not a great wage, but better than $1. 10 out of 22 got $7 an hour. 3 out of 22 got $10 an hour. $15 an hour, nobody got that. And over here, 2 people were lucky enough to get a $25 an hour wage. So the next thing we're supposed to do, and this is review from yesterday, is to calculate that expected value of X. So let's remember how to do that. Let's write it over here. We're going to do 1 multiplied by 5 out of 22 plus 5, the outcome, multiplied by the probability of that outcome, 2 out of 22. And we're going to add to that the outcome 7, multiplied by the probability of a 7, which is 10 out of 22, plus the next outcome is $10 an hour, multiplied by the probability of $10 an hour, which looks like 3 out of 22. Plus the next outcome is 15 multiplied by the probability of 15, which we calculated 0 out of 22. And then we'll do the last one, which is 25 multiplied by the probability of $25 an hour, which we got as a 22. And we should get a number there. And that's going to be $7.5 an hour. Yeah, okay, so we're supposed to interpret that. So this is the same probability, the same mean interpretation that we always have, and that's if we drew wages many, many times, the average wage will be about $7.50. So, moving on to what about recall from Chapter 1 that the standard deviation tells us the typical distance from the mean. That's the interpretation for sure. We're going to complete the table to calculate the standard deviation for the probability distribution. So let's take a look at this first one. The first one is, well, what is the distance from the mean? Well, if we do 1 minus 7.5, we get a negative 6.5. That's how far that is from the mean. Next, what if we take that number, the distance from the mean, and we square that? So negative 6.5 squared. That's going to be 42.25, and then we're going to weight that because this is not equally weighted, so we're going to multiply that by 5 out of 22. The probability of getting a 1 was 5 out of 22. So over here, we'll just do the scratch. If we do 42.25, and we multiply that by 5 over 22, we get 9.60. And we're going to continue that for the next one. So the next value is 5. How far is that from the mean? Well, if I do 5 minus the mean of 7.5, I get a negative 2.5. Negative 2.5 multiplied by negative 2.5. That's 6.25. And what is the weight of that value of 5? Well, over here, that value of 5 has a weight of 2.22. Let me highlight that. 5 has a weight of 2.22. So we're going to take that squared distance and we're going to multiply that by 2.2 out of 22. So we're going to do 6.25. We're going to multiply that by 2 out of 22. That gives us 0.568. Notice that the outcome of $5 an hour, that has a lot less than the probability of $1 an hour. So this number here ends up being a lot less than this number right here. Let's do one more of these. We've got the outcome of 7. 7 minus 7.5, that's going to be the distance from the mean. So we are about 0.5 less than the mean. We're going to square that, negative 0.5 multiplied by negative 0.5. That's 0.25. Let's come back up over here and let's see the mean or 7 has a probability of 10 out of 22. So now we have a higher probability of this happening. So when we come down over here, we're going to multiply 0.25 multiplied by that 10 out of 22. So 0.25 multiplied by 10 out of 22, that's going to give me 0.114. And we'll just go ahead and do the rest of these lines really quick. Now this is an interesting one. You might be wondering how we're getting the 0 here. And let's remember that the probability of a 15 was actually 0 out of 22. So if we multiply that, 0 out of 22 multiplied by 56.25, that's going to give us our 0. Just like before, now that we have our weighted distances from the mean, we're going to add them up, just like we would for a regular standard deviation. That's 38.934. And then now, at the very end here, we're going to take a square root. Now there's our standard deviation. Now obviously, this is a lot of process, so if you want to not do all of this process, and I can understand why, we can take a look at how to do this on a calculator. So let's grab our calculator, and we're going to just clear off. We'll do what we normally do, and we'll go to Stat, Edit, clear off these lists so we can put our new ones in. And let's put in our outcomes over here, 1, 5, 7, 10, 15, and 25. Next, we'll put our probabilities here, 5 out of 22, 2 out of 22, 10 out of 22, 3 out of 22, 0, and finally 2 out of 22. Now that we have that discrete probability function in our calculator, the discrete probability table, we're going to go Quit, and we're going to go to someplace familiar. Stat, calculate 1var stats. Okay. Now this is actually why we have the frequency list. So list, our values are, the wages are in list 1. Frequency list now, we can put list 2 here because that's going to be the probability list, the list of the probabilities of them happening. And when we calculate this now, this will give us our mean of 7.5, which we knew before. and our standard deviation of 6.24, which is what we had calculated down over here. So that's a really quick way of figuring out standard deviation using your calculator, which of course you're always going to have access to. So what is standard deviation? Well, that's going to be a typical distance from the mean. So the wages typically vary by about 6.24 from the mean of 750. While we're at it, we should take a look at the formula for standard deviation, and that's going to be the square root of xi minus x bar. Remember, xi minus x bar is the distance from the mean. You square that and you multiply it by the probability of that xi occurring. Square root it and you're done. Okay, so let's look at the next one. And let's see, Mr. Ferreria decides that he would rather assign wages so that employees could get any amount between $10 and $20. Now, any amount really means any amount, whether that's $11 or $11.1 or $11.125. Any amount in between there, and all amounts are equally likely. So what is that going to look like? Well, that's going to be a uniform distribution. You could ignore this middle part right over here. Ignore all of this for now. And just concentrate on the large light blue rectangle. And that's what a uniform distribution looks like. Every outcome is equally likely, so you get this rectangle. Now the base here goes from 10 to 20, which is a distance of 10 units. So the height here has to be 1/10, so that the area of this rectangle would be 1. Now for any probability distribution, if you remember, the area has to be equal to 1. So that's what we look like for our uniform distribution. Now the next one here is, what's the probability that an employee makes between 12 and 12.50? That's why we have this marked off over here, between 12 and 12.50. And when we're doing this, we ask, well, what shape does this make over here? What shape is this? And that was, I know it's a really ugly brown color right going on right there, but what shape is that? That's definitely a rectangle. And in a probability distribution, area is the same, probability is the same thing as area. And to get the area of a rectangle, we got to figure out the base of the rectangle, which is the distance from 12 to 12.5, which is 12.5 minus 12. That's 0.5. The height of this rectangle here, that's going to be 1/10. The height of, well, anything here is going to be 1/10. So the area of the rectangle would be base times height, which is 0.5 multiplied by 0.1, or 0.05. So the probability that the wage is between $12 and $12.5 or $12.50, well, that's 0.05, about 5%. So the big thing here, the big formula here that we did was this standard deviation formula. And remember, you don't actually have to use that formula pretty much ever. You can find that standard deviation using your calculator. We'll remind you again about the way that a interpretation for a standard deviation, it's a typical distance from the mean. And then the idea of a probability distribution function where area is the same thing as the probability. That brings us to our day 2, important ideas. We talked about a lot of this stuff already. So we have the standard deviation. There's that formula again. And then also we have sigma squared, which is the variance. That formula is just the square of the standard deviation. So just find standard deviation first and then square it. Now the probability for a continuous probability distribution function, this is a lot of what we did previously. And area is the same thing as probability. Now the one probability function that we're going to end up using the most, that's going to be the normal curve. So all the tools that we learned before for normal curves, all of the z-scores and using normal CDF to figure things out, figure out probability, that's still going to be our main tools here. So let's check our understanding. The heights of young women can be modeled by a normal distribution with a mean of 64 and a standard deviation of 2.7. So suppose we chose a young woman at random. Let y be equal to the height of that young woman. So the question, number one, is what type of variable is y? Is that discrete or is that continuous? And since any height is possible, or all heights are possible on any interval, we would say that this is a continuous distribution function. There are not certain set places where we have height. It could be anything in between any two numbers. Now the standard deviation is 2.7. How do we interpret that? Well, we would say that the heights typically vary by about 2.7 from the mean height of 64 inches. Now over here for number 3, we're going to find the probability that the young woman's height is less than 63 inches. What's the probability that she is less than 5'3" here? Now, less than or equal to or less than, that really doesn't matter in terms of our continuous probability distribution function. You calculate them exactly the same way. So that's what we're going to do. We're going to start off with a picture. Now, it might have been a while since we did this, so I'll remind you that in our normal curve, the mean is the center here with a z-score of 0. And our mean is 64. So those line up on top of each other right at the center here. The next thing to do is figure out where is 63. And if you remember that the standard deviation was 2.7 inches, so this here at -1, that would be 64 minus 2.7. So I think that's what, 61.3. So 63 should be somewhere between 61 and 64. That's why we're kind of putting it right in the middle over here. We don't know exactly where that is because we don't know the exact z-score. So we'll figure that out now. What is the z-score here? So our z-score is going to be our measurement 63 minus 64 divided by our standard deviation of 2.7. That 2.7 is the standard deviation. 64 is our mean. And 63 is, of course, our measurement that we're interested in, 63 over here. So we would write on our paper that the probability that the height is less than 63 inches, that's going to be the same thing as the probability that our z-score is less than -3.7. And then we're going to grab our calculator to get that number. Over here on our calculator, we're going to go ahead and grab our distribution, normal CDF. We'll do this a couple different ways. We'll start by doing this with let's do this in context. The smallest height is 0. The big height that we're interested in is 63. So we're interested in heights between 0 and 63 inches. Mean of 64, standard deviation of 2.7. We'll paste that together and give ourselves, a height of 0, or a probability of 0.3555. Now the other way to do this would be to use z-scores. So we're going to go from a z-score of -infinity, -1, E99, and we're going to go to our z-score. What was our z-score? -3.7. The mean for the z-scores are 0, standard deviation is 1, and we should get a number that's pretty close. No, that's not really, I see what I did. I put a -3.7. My mistake. Let's just fix that real quick. And we'll put a -0.37. 0.37. There we go. All right, 3557 this time. So you can see really close. It says to interpret the value, so we would say that there is a probability of 0.3556, 3557, whichever it is, that the randomly selected female is less than 63 inches in height. Now, the next one. Between 68 and 70, we will again have a diagram here. 64 is the mean, and that mean is right in the middle here. Remember that the standard deviation is 2.7, so 64 plus 2.7, that's what, 66.7. So 68 is just after that. Add another standard deviation, 64 plus 2.7 plus 2.7. That's going to give us 69.4, and that means that right over here at 2, this is a 69.4 inches tall. So 70 should be to the right of that. That's why we have 70 to the right of 2. Now we've highlighted that area between 68 and 70, and we're going to find the two z-scores. So the first one, 68 minus 64 on top of 2.7, that gives us a z-score of 1.482. Then our second one, we have 70 minus 64 divided by the standard deviation of 2.7, giving us a z-score of 2.222. Now the probability that the height is between 68 and 70, that's the same thing as a probability of a z-score between 1.482 and 2.222. Using the same calculator tricks, we're going to get that our area here is 0.0561. So that does it for us. Hopefully you remember how to use the normal distribution functions on your calculator, because I have a feeling that you will be using them for this chapter as well. So there you have it. Have a good day, everyone, and happy stats to you. See you next time.